Hello, this is Group 4 OpenDoc, and this is our live demonstration. So going over the project review, our entire idea was that we want to cut down on the time spent on reading through reviews to find the doctor of your choice, but you just put your uh, necessities and specifications into our website, and we find the top 5 most fitting doctors for you. So we did this by putting the doctor reviews from Atlanta-based family medicine doctors into a vector database and doing a similarity search. So, in a traditional vector space recommendation system, uh, we make review vectors through embedding and average the review vectors into one single vector to represent the doctor. However, the problem is that it often loses meaning and nuances of the reviews. For example, let's say we're trying to represent the doctors with expertise and bedside manner. Usually, most reviews only mention one or two aspects of the doctor, and you can see in our example that 5 reviews only talk about bedside manner and vice versa. With the traditional vector system, the reviews are averaged out to the red star shown on the left. Um, and you can see that it does not really represent the reviews. Therefore, we introduced K-centroid system, which we basically use multiple centroids for review vectors. And you can see that these two centroids represent the review vectors much better on the right side. So this is further technical highlights. I just talked about 1, 2, and 3. And additionally, using multiple centroids boosts precision for nuanced queries and enables aspect-focused rankings. One of the main challenges we had in the data gathering process was with converting the numerical helpful ratings into semantic rating to be appended to the patient reviews. We used the scaling system of 1 equals very poor, 2 is poor, 3 is average, and so on, and concatenated this with the type of helpful rating. For example, appointment scheduling would go into average appointment scheduling or very helpful appointment scheduling. And we did this to increase the size of the reviews because the review length was usually very short. Um, the problem with this is that we applied this method to every single review. So for the first 25-ish words, most of the reviews look almost identical in the vector space. We tackled this problem by using a more fine-tuned model that looked at the uniqueness of the uh, remaining of the review better. Another issue was sourcing the data. Of the 5 major doctor review sites, only 2 allowed us to scrape without being blocked, and we had to crawl them with custom crawlers for each since no API was available. The number of reviews per doctors varied significantly. Some have as few as 3 reviews, while others have up to 40. To account for this variability, we dynamically determine the number of clusters using the equation shown on the very bottom. So for testing and quality assurance, we identified reviews with the review intention of returning. For example, the doctor is very kind, and using an LLM, we transform that into something more similar to a user query. For example, I am looking for a kind doctor. Then we use this query to search through our vector database to see to measure the top K precision. And we realized that the results came out to a total review of 2049 test set of n equals 196, and then the top 5 precision was 32%, and then the top 20 precision was 50.51%. This is most likely because there are doctors with very similar reviews. For example, one doctor is not going to be the only kind doctor, which means that even if you have the intent of returning, a doctor who has a lot more reviews stating kind would get a higher similarity score, thus returned in our system. And for um, further improvements, we want to make an objective rating of the doctors, which means that sometimes, right now we have the objective rating, which means that they're given a rating based on the reviews currently existing, but we want to change the reviews based on your requests. For example, by changing the weighing of the different factors to the user's preference. For example, if the user does not care about the kindness of the doctor at all, then we could lower that rating and then lower the weight on that part of the weighting and then use weigh the rest of the categories to give a better, more personalized rating. Additionally, we would like to include a user feedback loop such that we can constantly evaluate our recommendation system. And then we want to include explainability and transparency to show why the matching is happening the way it is. Another approach that we're trying to implement um, is an alternative approach to the vector space. Rather than representing each review as a vector, we would instead be applying an exhaustive search over all reviews to classify them into topics such as communication, helpfulness, empathy, and so forth. And we will then apply a semantic analysis on each of these topics and give them a weight or a score. And this would end up converting all the reviews into multiple score topics that we can apply a better understanding to each review and more attributes. We will then test this in comparison to the vector space in our search. And here is our demo. So this is our website. You can put in the location, for example, zip code of 30030, which is the Emory zip code, I believe. The insurance one does not work right now, so I'm going to skip through that. And you can just slide to your preference. Let's say we want a really kind doctor. Um, and then we don't care about this. And then we'll give it an example query. It can be, I want someone to be super kind and good to good with handling children. You can press search. And here are the results. For the results, we have the net rating, the address, the summary generated from the reviews, and then a couple of the reviews from the data set that we used. We can go back and we can also try a different search. We'll just keep the location blank for now and try the opposite side. Double. Doctor Who can answer my questions. And this generates a completely different set of results in the same format. Here we can see that the term knowledgeable coming in. Right here, we can see knowledgeable again. We're trying to implement a feature such that we could highlight these features so that people do not have to manually look for these. Here, again, good knowledge. And yeah, this is our product. Thank you so much for tuning in.